For centuries, the phenomenon of electricity remained shrouded in mystery, a hidden force only hinted at by nature's occasional displays. Ancient civilizations, observing the electrifying power of lightning strikes, attributed this awe-inspiring phenomenon to the wrath of the gods. Yet even in these early times, curious minds sought to understand the forces at play. The ancient Greeks, known for their inquisitive nature and thirst for knowledge, were among the first to document their observations of electricity. They discovered that rubbing amber, a fossilized tree resin, against fur or wool would attract small, lightweight objects. This seemingly magical property, which we now know as static electricity, sparked their curiosity. While the Greeks' understanding of electricity remained rudimentary, their observations laid the groundwork for future scientific inquiry. Their experiments, simple as they were, marked the beginning of humanity's long and fascinating journey to unravel the secrets of this powerful force. Little did they know that their early explorations would one day illuminate the world and power the modern age. As centuries passed, the torch of scientific inquiry was carried forward by brilliant minds who dared to delve deeper into the mysteries of electricity. These pioneers laid the groundwork for our modern understanding, transforming the way we live and interact with the world around us. In the 17th century, English scientist William Gilbert, often hailed as the father of electricity, made significant contributions to the field. His curiosity and methodical approach set the stage for future discoveries. Gilbert was the first to use the term electricus, derived from the Greek word for amber, to describe the attractive force observed by the ancients. This term would eventually evolve into the word we use today, electricity. Gilbert conducted extensive experiments with various materials, meticulously documenting his findings. His rigorous scientific methods were revolutionary at the time, providing a systematic approach to studying electrical phenomena. He distinguished between the attractive properties of amber and the magnetic properties of lodestone, establishing electricity as a distinct phenomenon. This differentiation was crucial in advancing the study of both magnetism and electricity. His groundbreaking work, published in his influential book De Magnete, laid the foundation for future generations of scientists. De Magnete was not just a book, it was a comprehensive treatise that inspired countless researchers to explore the enigmatic world of electricity. Another pivotal figure in the history of electricity was the American polymath Benjamin Franklin. Known for his diverse interests and inventive spirit, Franklin's contributions to the field were both practical and theoretical. Franklin's legendary kite experiment, conducted in 1752, demonstrated the connection between lightning and electricity. This bold experiment was a turning point, providing tangible evidence of the electrical nature of lightning. By flying a kite with a key attached during a thunderstorm, Franklin bravely proved that lightning was a form of electrical discharge. This experiment not only confirmed his theories, but also paved the way for the development of lightning rods, which have since saved countless lives and properties from the destructive force of lightning. The pioneering work of Gilbert Franklin and many others has led to the incredible advancements we see today. From the simple light bulb to the complex circuitry of modern electronics, our world is powered by the principles they uncovered. Their legacy lives on in every flicker of a light switch and every charge of a smartphone, reminding us of the endless possibilities that arise from the pursuit of knowledge. The 18th and 19th centuries witnessed a flurry of groundbreaking discoveries that propelled the understanding and utilization of electricity forward. In 1800, Italian physicist Alessandro Volta invented the first electric battery, the voltaic pile, marking a pivotal moment in the history of electricity. Volta's invention provided a reliable and controllable source of electric current, paving the way for countless technological advancements. Volta's battery consisted of alternating discs of zinc and copper, separated by cloth soaked in salt water. This arrangement generated a continuous flow of electrical current, demonstrating that electricity could be produced chemically. Volta's invention revolutionized the study of electricity, providing scientists with a tool to experiment and explore its properties in unprecedented ways. Building on Volta's groundbreaking work, English scientist Michael Faraday made a monumental discovery in 1831, electromagnetic induction. Faraday discovered that moving a magnet near a wire could induce an electric current in the wire, a fundamental principle that formed the basis for electric generators and transformers. Illuminating the world, Edison, Tesla, and the dawn of electric light. The The late 19th century witnessed the transformative power of electricity as it illuminated homes and streets, forever changing the fabric of society. The advent of electric light not only extended the day into night but also revolutionized industries, improved safety, and enhanced the quality of life for countless people. It was a time of great innovation and fierce competition among inventors striving to harness the power of electricity. Thomas Edison, a prolific inventor and businessman, is credited with developing the first commercially viable incandescent light bulb in 1879. Edison's relentless experimentation and keen business acumen allowed him to bring electric light to the masses, making it an integral part of modern life. His work laid the groundwork for the electrification of entire cities and the creation of a new industry. Edison's invention, though not the first incandescent bulb, was revolutionary in its practicality and affordability. Prior attempts at creating electric light were often too expensive, unreliable, or short-lived. Edison's design, however, was able to burn for hundreds of hours, making it a viable option for widespread use. Edison's light bulb consisted of a thin filament of carbonized bamboo enclosed in a glass bulb from which air had been removed. This vacuum prevented the filament from burning up quickly, allowing it to glow brightly for extended periods. The choice of bamboo was crucial, as it provided a durable and efficient filament that could withstand the high temperatures required for incandescence. When an electric current passed through the filament, it heated up and glowed brightly, providing a steady and reliable source of light. This simple yet ingenious design became the cornerstone of Edison's lighting system, which included generators, wiring, and fixtures to bring electric light into homes and businesses. Edison's invention marked the beginning of the end for gas lighting, ushering in a new era of electric illumination. The transition from gas to electric light was not immediate, but the advantages of electric lighting, such as reduced fire hazards, lower maintenance costs, and brighter, more consistent light, soon became apparent. Cities around the world began to adopt electric lighting, transforming urban landscapes and setting the stage for further technological advancements. While Edison championed direct current, or DC, for his electrical systems, a brilliant Serbian-American inventor named Nikola Tesla emerged as a proponent of alternating current, or AC. Tesla's vision of a more efficient and scalable electrical system challenged Edison's dominance and sparked a fierce rivalry between the two inventors. Tesla's work on AC systems proved to be more efficient and practical for long-distance power transmission, and his inventions laid the foundation for the modern electrical grid. Unlike DC, which required power stations to be located close to the end users, AC could be transmitted over much greater distances with minimal loss of power. This breakthrough enabled the widespread distribution of electricity, connecting rural and urban areas alike. The war of the currents between Edison and Tesla captivated the world, ultimately leading to the widespread adoption of AC systems. This epic battle of ideas and technologies not only shaped the future of electrical power, but also highlighted the importance of innovation and competition in driving progress. Today, the legacy of Edison and Tesla lives on in the electric lights that illuminate our world and the power systems that sustain our modern way of life. Powering progress. The rise of the electrical grid and the Industrial Revolution. This period marked a significant shift in how societies functioned, laying the groundwork for the modern world. The development of the electrical grid in the late 19th and early 20th centuries marked a turning point in human history, ushering in an era of unprecedented technological advancement and societal transformation. Before this, energy sources were limited and often inefficient, relying heavily on steam engines and manual labor. The electrical grid, a complex network of power stations, transmission lines, and transformers, enabled the efficient distribution of electricity over long distances, bringing power to homes, businesses, and industries on a massive scale. This infrastructure was not built overnight. It required years of innovation, investment, and collaboration among scientists, engineers, and policymakers. The electrification of factories and industrial processes revolutionized manufacturing, leading to increased productivity, reduced costs, and the development of new technologies. Machines that once relied on steam or human power could now operate more efficiently and continuously, transforming the scale and scope of production. The availability of reliable and affordable electricity fueled the Second Industrial Revolution, a period of rapid industrial growth and innovation that transformed economies and societies around the world. This era saw the rise of mass production techniques, such as the assembly line, which further boosted industrial output and economic growth. New industries emerged, driven by the power of electricity, creating jobs and raising living standards. The electrical grid not only powered factories but also enabled the development of new sectors such as telecommunications, entertainment, and consumer electronics. The electrical grid also played a vital role in the growth of cities. Urban areas expanded rapidly as electricity made it possible to build taller buildings, improve public services, and enhance the quality of life for residents. Electric street lighting made urban areas safer and more vibrant at night, while electric trams and subways transformed urban transportation, allowing people to live further from their workplaces and city centers. This mobility contributed to the growth of suburbs and the spread of urbanization. The rise of the electrical grid was instrumental in shaping the modern urban landscape we know today. It laid the foundation for the interconnected, electrified world we live in, influencing everything from how we work and communicate to how we entertain ourselves and move around our cities. The legacy of this transformation continues to impact our daily lives, driving ongoing innovation and progress.